Hello. During this lesson, we will talk about addresses. You already approached the concept of address with Laurent Tautane during week 1 with the postal address. If we keep this analogy which fairly corresponds to what is currently going on in networks, we can say that an address is a way to uniquely designate a machine on the network. We can start by asking ourselves when the address concept is required. When two machines are connected via a cable, the address concept is useless because when the first machine sends a packet, it is necessarily intended for the machine on the other side of the cable. The address concept becomes important when there are several machines on the network or when a broadcasting medium is used. In this case, it is essential to locate the machine's identity and maybe also its location. Now that we know we need an address concept, we can use the OSI reference model that you already saw during the previous weeks. If we look at this model by starting from the lower layers, we see that we already need an address concept from layer 2. This address is known as the MAC address. It is coded over 48 bits, 6 bytes, and uniquely identifies a network interface worldwide. This interface is identified with those 6 bytes which can be divided in 2 parts. The first 3 bytes identify the manufacturer of the interface, for example, the manufacturer of the network card installed in your machine. The next 3 bytes identify a serial number from this manufacturer for this specific equipment. If we had a look at the MAC address of my machine, we would see it starts with 00:25:4B. If you look at the available references on the web, you will see that corresponds to Apple, who manufactured the network card I am using. Let's have a look at the address on layer 3. Here it becomes really important because this layer will introduce intermediate relays to transport information to the destination. We will see that the address will take different forms depending on the protocol used. Let's take IPv4 as an example. Here the address is coded over 32 bits. If we take a look at its structure, we can see that the first part is made of a prefix with a variable length which identifies the network on which the machine is located. The rest of the address identifies the machine's interface on this network. Let's now take IPv6 as an example. The address is now coded over 128 bits. Once again, we have the network prefix as the first part followed by 64 bits to identify the machine's interface on the network. In both cases, the address is hierarchical. Indeed, one part identifies the network prefix, thus, a set of machines that can be contacted. By contrast, we can compare it to the MAC address, which is flat since it only identifies one machine. Indeed, addressing several MAC addresses is not a way to define a group of particular users. We can also talk about addresses in layer 4 if we look at the ports which identify the protocol used in level 4. If we go higher, we can find an address concept in layer 7. Its form will depend on the considered application. Let's take mail as an example. When you write a mail to someone, you use an email address to identify this person. Let's take another example. If we look at web page browsing, you identify the page you want to browse by giving its URL, which corresponds to its address. During this lesson, we have seen the address concept. We said that an address uniquely identifies a machine or an interface on the network. We have seen that an address has different forms depending on the protocol used. We have also seen that an address can be the identity of a machine, its location, or both. We also talked about flat or hierarchical addresses depending on the fact that we can or cannot address a group of machines on the network.